Okay, so I'll start with the first segment, the first sheet. The first sheet is just looking at the sections. So if you look at this, let me go from the beginning. I think we had talked about this one before. So if you check the OGP, I think it's OGP 4346 or 8 or something. You see the probability of leakages from the different sizes of flanges, manual valves. I think there's a
Oh, sorry,
actuated valve.
sorry, please.
Please go
Is
on.
the OGP data available online? The OGP data, is it available online?
I thought you had the OGP. I think it's 4348.
No, I tried searching for it online before this meeting. I've not been able to get it.
The unfortunate thing is that my laptop was stolen because I used to have it.
Oh, okay. Oh,
So I'll need to
yeah.
check to see if I have it in my archives. But I know that I can't remember how I got it, but I'll check. We'll check after this meeting. So
Okay.
this data you get it from OGP. Remember,
From
in our
OGP.
own case, we have only one section. We have only one isolatable section, right?
Yes. Yes.
So we are not dividing into five in our case. We are just looking for any flange that is less than 2 inches, any flange that is between 3 inches and 6 inches, anything that is
Mm.
between 7 and 12. So you are doing part count. So this is the parts count that they talk about when you hear about parts count.
Okay. Please. So that 2 inches means all the flanges that are between
Two
0
inches
and
and
2
below.
inches and below, right?
Between 0 and 2, yes. So you get the P&ID and you're checking to see how many
Oh,
flanges do we have that are less than 2 inches, or so this one is less than 2 inches. Then the
oh,
next one is between 2 and 6. Then the
between
next
two and
one,
six. That's
yes, because
exclusive of two, inclusive of six, right?
no, it
That's greater than.
includes two. So if you see this one is less than 2. So it didn't say less than or equal to 2. So if you
Oh, not
have
less than.
a 2-inch flange, you don't count it here. You count your 2-inch flange here because it is
I can
this one is from 2 to 6. This
from two to
column
six.
C.
So
Yes,
less than six. Six is not inclusive.
it's 6 is inclusive because it's less than and equal to and equal to.
Oh, less than or equal to. Okay. On
So
my page, no, it's only less than. I mean, surely just six.
what?
Okay, okay, okay. Yes, I can see now. Okay. I
You
was
can
on a
see it's
different
less
page.
than or equal to 6.
Yeah, less than or equal to six. Okay, okay. I was on a different page. Okay.
So for D, you see that it's what do you call it? Sorry, let
Then less
me
or equal.
less than or equal to 12, which means it's between 7 inches and 12, or anything
To 12.
above 6 and up to
Oh,
12. And so
okay.
you do that for flanges, you do it for manual valves, you do it for actuated valves, you do it
Please,
for
that's one of the challenges. What differentiates actuated valves from manual valves? I couldn't locate which ones are
so your
actuated.
manual valves do not have any control function. So the ones that are actuated valves are like your LCVs, your PCVs, your FCVs, the ones that they have you can send signals to them and they will take executive action. Those are the
Oh,
actuated valves.
so those ones that have like instruments on top of them.
Uh-huh.
Okay, okay. So inclusive of PSV. I'm with the
So your PSVs, well, I guess so.
Okay.
And if you have any instrument connections, you can
Connection
capture them under this.
on that is okay. Okay, that's good.
Then your pressure vessels, you put them in
Okay.
one, any pressure vessels within your system, you count them separately. Then any
Okay.
compressors that you have, that's a centrifugal compressors, you count
Mm,
them. Any centrifugal pumps, you count them separately. if you have any heat exchange that you count them. So if you get that OGP 434, I think it's 4348. I can't remember if it's 8 or 6. It gives you
Okay.
the different parts of things that you are counting in your parts count. So in this case,
Okay.
these are the only ones that were applicable for this project. That's why we only put these ones. But it's still important to
Okay.
get that OGP 4348 to be sure that there's
Okay.
nothing else that you should be putting in. So after the first part of your work is this part count.
Part count. Okay.
Then when you're done with the parts count, you
Mm.
now come to this summation.
Okay.
This summation is basically it's about the same thing, really. If you ask me, it's basically I think it's the same. Really, I don't know why we had. Okay, no, this is no. I'm still in section. So sorry. Summation is counting every your 2 inch valve. I'm trying to remember what exactly it is. Why we have so sex sum of A and B. Let me see what was that. A and B. I'm trying to remember what we did here. Ah, okay. 1.1. I can't remember what we did here. So this one should be 2, not 1.1.
Okay.
I'm trying to remember why we had this formula.
Separation.
Yeah, so this one should be 3. So it's about the same thing, really, if you ask me, because I think it's the
Okay.
same. I think it's the
Okay.
same information as we had there. I'm
Okay.
not sure why exactly we had this sum if thing. So this summation, this one, he separated the liquid sections from the gas section, vapor sections. But in our case, we we are just looking at one isolatable section. But so we don't need this to we don't need to
Oh.
populate these two ones.
Oh.
Okay, so I think the OGP data is here. Thankfully,
Okay.
I think the OGP
Does it
data
cover
that
all?
you I believe it covers all, but it will still be helpful to open up the OGP and confirm that the data that we have here is accurate.
Okay. And be sure that there are no other equipments apart. Maybe there are equipments that are
That is what I have. But if you ask me, these people they are not paying us enough for all this work. I'll
for
just
all
say
this one.
do the barest minimum for them. But excuse me, if
Okay.
you can get the OGP, the sheet, that'll be fine. At least just to be sure that you got the right thing. Then your frequency analysis, what you're doing for your frequency analysis is basically just to because there's supposed to be another sheet that gives us the IRPA. I'm wondering, I have to find that one. So in this,
I
so
think
for this, sorry,
I think IRPA is still by the right.
yeah, because you have to combine things to get the I,
The IR.
IRPA.
Okay.
So
Okay.
what we now did was that remember you've got the OGP data and you've done your parts count. So we need to put them together to get the frequency.
Okay.
So that's what this sheet is doing. So if you see, this is multiplying OGP N3 by, in this case, this section one was for vapor, but in our own case, we don't have a separate one. So all we will just be doing will be OGP data times sections because we haven't separated.
OGP data multiplied by sections.
But let me just
Okay. That.
explain what's going on here. So, for example, we want to see the frequency of having
Mm.
it's a 1 to 3 inch leak, size
Mm.
leak in an actuated valve that is 2 inches and below, or less than or equal to 2 inches. So what we did was that we took, if you see this OGP data N3, I'll go back there so you can see what is actually there. OGP
Okay.
data N3 is Okay, so this one I think was filtered or something. Okay, N3. So if you see N3, N3 is 1 to 3 inches for actuated valves. The frequency of a leak size of 1 to 3 inches on a 2-inch actuated valve. So that's what OGP data N3 is. So let's go back
Okay.
to the frequency analysis. So basically, you're just doing the math, but you don't want to be hand calculating. So you're using Excel. That's all what you're doing. Then you now
Oh,
multiply by this. In this case, because this section is vapor, so you can only find section one in this vapor one. So is vapor J3, right? So this is J and this is 3. So you see, this is the number of, so part count is how many 2-inch actuated valves do we have in section one. That's all they've done. So what they've done is that whatever number of actuated valves we had that were 2 inches and below in section one, they've multiplied it by the frequency, OGP frequency data. So that's all we are doing here.
okay. That vapor J3, there's nothing there, right?
Because
Vapor
it's
J3
zero, so everything now becomes zero.
is zero. So that is okay. The frequency is zero.
So you're taking each part, you're multiplying. So for the 1 to 3 leak size, you need to know how many less than or equal to 2-inch actuated valves are in section one. And we want to see the potential likelihood of having a 1 to 3 inch leak on that 2-inch actuated valve. So you have done it
Okay.
for the 2-inch valves, you do it for the 6-inch, you do it for the 12, you do it across all of this, then you now sum them all up. That's
Okay.
actually
That,
this last one. So you are
okay.
doing, as in, you can imagine how much back-breaking work it would be if you were going to be doing it individually, but you can set it up in Excel so you don't
Yeah.
have to do it.
Okay.
So, but the only thing you will now have to do if you are taking this sheet, because you don't need to do summation L and Q, you're now going to have to change everywhere where you had summation VAP and summation LQ, and you just be using only summation in that case,
Okay.
or if you like
Okay.
sections, because we've already put the data that we should have just left in submission. So you can even get rid of all these three tabs and just focus on section. So everywhere, so it should just be section OGP data and frequency analysis. So everywhere that you find summation VAP or summation LQ, you can replace it with sections actually
Okay.
in this Excel
Okay.
sheet. And your work. So once you set this part of this Excel sheet up well,
Mm.
then you come to these sections, you now go and count each of those values. So once you do your parts count and you set up your spreadsheet, your frequency analysis, it should be good to go.
Okay. Okay.
So
Uh,
so that's for frequency. So when you're done with frequency analysis, then we can go on to talk about uh, the IRP. I think this spreadsheet should continue now because I know that we went on to do this.
yeah, it continues there. The next one is failure cases.
This what?
Failure
Hey,
cases. Yeah.
because there should be more on this sheet. Like so,
Uh,
I've already messed up this one because of the way this my spreadsheet is behaving. I sorry, this my
okay.
mouse
Okay.
because I don't know why this one something has happened here. Why is this one should be C8 to C11? So but we'll need to tailor this, of course, for our own system because
Mm.
when you've done all your calculations and all on this frequency sheet, we now need to
Mm.
come. Which one are we calling small? For example, the small, if you can see, is frequency analysis U3 plus. Let me see. This my mouse is. So you see, it's U3 plus U4, right? So now let's go and
Okay.
see what U3 plus and U4 are. So this is U3 plus U4. So the small adds from leak size is 1 to 10. That's what is summing up
D3.
as
Okay, that's 1 to 10. 1 to 3 and the 3 to 10.
so that's what we are calling small. So what we are
Small.
saying is that the small leak sizes, what are we
Mm,
considering to be small? Is
mm,
1 to 10. Medium is 10 to something. Let me see. It's between 10 and 50 is medium. Then
okay.
large. Large is 50 to 150, I think. Then full
Okay.
bore is anything greater than 150.
Okay.
So that's all that we did on this sheet.
Sorry,
Then
those
after that,
greater than 150, are they inches or millimeter?
what?
Those greater than 150, are those values inches? Those leak sizes rather, are they inches or millimeter?
Yeah, then I think they're in mm.
Okay, because I wanted to say that for you to have a leak size of 150 inches, that would be catastrophic.
I think they're mm.
Okay, man. Okay,
Okay. So after that, you go into your gas inventory.
okay.
Um, these numbers, I'll need to check where we got them from. I think they are from another OGP or something. I'll need to confirm. But I can almost bet that I can almost say that we can carry them over for this project because I can
Oh,
tell you that SPDC probably Snepco they don't have any event data they want to give us,
mm,
but if they have it, we can use it. Otherwise, we
but,
can just repeat this one. We use it. So
mm,
basically, when the leak occurs, one of two
mm,
things can happen. It may ignite immediately or it may not ignite.
yes.
So if it ignites immediately, that's the yes. The likelihood that we know is of it igniting immediately is about 0.1%,
Okay,
because 99.9% of the time you will not find a source of ignition
okay,
immediately.
okay.
So you see, so that's basic. So we are just basically putting numbers to what could potentially happen,
Mm,
which is the inventory.
oh,
So assuming it doesn't ignite and
yeah,
you expect your gas detection to pick it, right?
okay,
Or gas detector. So we have assumed that 95% of the time the gas detector works and it will
okay.
pick it. So if
Mm,
the gas detector works, that's where it goes to no, and which
mm,
means that we have detected it. The next question we ask ourselves is that can we isolate? How likely
okay,
is it for the isolation to fail? So if the isolation fails, so if the isolation fails, that's where it's the 0.01, but 99% of the time the isolation works. And if that is the
uh,
case, so we calculate. So basically, the way we got this number that you're seeing here is by multiplying all of these numbers from here 0.999 times 0.95 times 0.99. If you do them in your calculator, you will get. So anyways, already here. You don't need to do it on your calculator. We've already done the work on this. We have this sheet.
oh,
That's where we've done all the calculations. But we left this because we need to take this picture and
mm.
put in the report. So that's the reason why we did it.
But
Did it.
sorry, at the time, is it the client that gave you these figures?
If I remember, I think we got the numbers from the client, yes. So,
Uh,
but because you've already got something that you can, so we can present this in our first revision, and then if they
okay,
have any numbers different from what we have, then they give us and we plug it in. If not, we just
okay,
carry on. We just tell them that we've made the assumption based on our previous experience.
okay. But one will have thought that share will be of the highest standard, and have all
Yeah.
these things, you know.
So,
Eh,
so that they don't waste our time, because if we go and send message and say we are asking them for that one, now it will take us another 2 months.
exactly. exactly.
So the way to catch them is to give them whatever we have. Then if they have something, they will bring it out.
The next
If they
thing.
don't have it,
Okay.
we keep it. We keep this one. So
Okay.
this is basically just
Sorry,
the
sorry,
way.
still on that gas event tree. The last
What?
column is still on that gas event tree.
Yes.
Uh, the last column is consequences. So we have a jet fire, unisolated jet fire, and all of those. Yeah. So is it
Uh-huh.
the value that we got for the this event frequency that informs which consequence we are going to pick?
Which
The consequence
consequence we
that
are going to what?
pick, whether it's going to be jet fire or vapor cloud
No, no, no.
explosion, or
So for example, for us to get a jet fire, for example, there has to be a leak. There has to
yeah.
be immediate ignition. Our fire detection has to fail. Then that's when
Oh,
we will have a jet fire consequence,
yeah. Okay. Okay. So
which
that
can.
means each of these branch, we automatically have the consequence that is in front of it.
So
Okay.
this is the jet fire is the natural consequence if all of this happen.
So this
Then
happen.
if you,
Okay.
let's say you have your leak, your fire detection fails, so you don't detect it, but you're able to, and your isolation also fails, for example,
Mm,
and your
mm,
deluge also fails.
mm.
That means that you have unisolated, well, both one and two actually unisolated. I think we had that as a comment eventually, that both
Okay.
one is unisolated because you didn't even try isolation. Your fire detection has already failed. So I'll just edit number one to also include it as unisolated jet fire
Unexpected.
rather than just writing jet fire. That's all.
Mm.
Then
So what is one and two eventually?
what?
If both are what we now distinguish one and two if both of them are still
Nothing.
unisolated?
Nothing.
Nothing.
So
Okay.
if we now want to know what the frequency of an unisolated jet fire will be, then we'll
Mm.
add all the three cases that are becoming unisolated jet fires, and that will
Okay.
be the frequency of us having an unisolated jet fire.
Oh, yeah. Okay.
So all what we are just saying is that if this happens and this happens and this happens, this is what the eventual consequence is.
Mm.
So we can get an unisolated jet fire if your fire detection fails. You can also
Mm.
get an unisolated jet fire if your fire detection actually works, but your isolation fails, for example, and the
Okay.
deluge also fails. Do you understand?
Yes. Yes, I do.
And even if the deluge does not fail, you still have an unisolated jet fire. It's just that uh, it will not escalate.
Mm. Okay.
So these are natural consequences as a result of the events. So this is just an event tree. So we
Okay.
then go ahead and calculate the frequency or frequencies of all of those things. So these numbers that you have in there,
Mm.
these numbers that you have in gas inventory are what we
Mm.
calculated here.
Okay.
So this is, you can see that this is when we did the actual multiplication. So it's whatever values we get here that we go back and go. So if Shell come back, for example, and say, oh no, the probability of our own fire detection failing is 0.04, for example, you know that you just
Yeah.
come here, change this to 0.04, which means that this one will change to 0.96.
Okay.
So this is where you
Okay.
come and play with all the numbers
Mm.
changes. So when you get your event tree frequency, then we now come to the consequence frequencies. So this where we put initially we separated jet fire from an isolated jet fire, but I would say that so I think this is potential escalation. No, I would say that these two columns B and C, we probably should be
Yeah.
able to collapse them together
Okay.
because both of them we can sum up the unisolated jet fire with potential for escalation in one. So this is where you now multiply the frequencies you got from this your from this case when you were summing up. So this is where we summed up all the values we got from here. So here we summed them up here. So you have your potential leak sizes and all here. Then you go ahead and multiply that by the frequency of each of, as in, for example, if it's a jet fire you want to happen, for example, you have to multiply. Oh God, I've messed something up somewhere. My mouse is faster than my than is faster than it should be. Okay, yeah, so if you look here, this is looking at failure cases C8 times event frequency O4. So let's see what failure frequency case C8 is. So C8 is for the total frequency for small leaks, for
Okay.
example. Huh?
Mm.
And then we go and check what event frequency O8 is. So O8 is isolated jet fire transient. So,
Okay.
okay, sorry, O4. I was wondering why we'll be doing O8. O4 is
Okay.
for a jet fire with potential escalation. So we are looking at a small leak leading to a jet fire. So that's what we've done here anyway. Small 7 mm leading to jet fire. So by the time you sum up the two, you'll probably just be doing jet fire here. This one will now be perhaps equal to failure cases times, then in parentheses, you do this event tree frequency O4 plus O5 so that you put them together. They won't be separate because they are the same.
Okay. Okay.
So you're basically working on your frequencies. So I think I was the one that after I did all of the calculation, I then came to I think I came to put to just put them in one easy table for someone to be able to quickly see.
Okay.
Not sure why exactly I did this. Yeah. So I think I put the isolated jet fire. I added up the isolated jet fires here.
That's fine. Okay.
And then I think
For the
here
debt transfer.
I added the isolated jet fires, whether they are deluged or transient together. I put the
Okay.
unisolated jet fires together, which was C3 and D3, whether it was going to escalate or not escalate. Then the VCE, I think I did G3 plus I3. Yeah, there were two types of BCs. Then the dispersing clouds too were two. So I think I added them up so that we'll have all the frequencies together in one place.
One place.
So this is
Okay.
consequence frequencies.
Okay.
So these numbers, you now have to use them in interpreting your IRPA. There's a way you
Mm.
combine them. So but I'll just say, let's first of all get this part of the spreadsheet sorted, then I'll go and look for the spreadsheet we use for the IRPA
For the RPA. Okay. Okay. And the PLM.
and PLL.
I mean, uh,
And
I,
hopefully maybe we would have been able to reach that down by that time. Maybe he'll be the
okay.
one to handle that part. Because I'm trying to remember because this is like 2 or 3 years later. So and
Wow.
it's not something I do frequently.
Mm.
So I'm really trying hard to remember everything that I did back then.
That's
And that's
you're
another
doing
reason
very
why I'm recording. So that
okay.
next time
Yeah.
I'm gonna have to
That's
just go and find the
that's true.
recording.
Mm.
Okay, I'll stop
Mm.
recording now.
Okay. Okay. Sorry. Okay. So the IRPA, PLL, and then I think there are three of those kinds of fish. They will come
There's
later.
potential loss of life. Is IRPA then LSIR? That's the last one.
Yes, IR. Yes, I was trying to remember.
LSIR, yes. So those ones, once we get these spreadsheets at least in a good enough shape, then we can maybe
Mm.
schedule another session, hopefully next week or something.
Okay. Okay. Okay.
So
I really appreciate.
I'll
Okay.
search for that one. So hopefully you can use this week to tidy up
Uh,
the part
okay.
count, then the
Okay.
spreadsheet, and just make it at least. So you have to delete all the other sections. Only section one will remain for us.
remain. Okay. Now, but as big as Shell is, they can't pay enough for us to do to do
Remember
a
that
thorough
we are
one.
recording this, so let's be mindful of what we are saying.
Okay. Okay, you can stop recording.
Because I need to stop recording. Because
Okay,
we never can tell where our recordings will go.
okay, sorry about that.